Okay, so previously we looked at solving a system of linear equations by graphing, and now we're going to look at it through substitution. Now, with substitution, the idea behind that is, let's say I had x equals 2, and I had another equation, we could say x plus 4 equals 6, okay? The idea behind substitution is if I know that x equals 2, then I can replace x with 2 and I still maintain equality, okay? So that's the idea behind substitution, is if these two are equal, then I can take that variable out and replace whatever it is equal to in. Of course, we're going to be substituting in an entire expression, but that's the simple idea behind substitution, okay? Now, there are 3 steps to this, and I'm going to show an example here that's already pre-made to kind of give you an idea of how that works. So step number 1 is we solve one of the equations for one of the variables, okay? So let's say I had a system of equations and we have our 2 equations here. We need to solve one of them so that they have either x by itself or y by itself. Now, if you're comfortable going into y equals mx plus b, you can solve for y and put it in y equals mx plus b every single time, and you should be fine, okay? If you feel comfortable with that, that's fine. But what we need to do is substitute this expression into the equation, into the second equation for the y variable, if that's what you're going to solve for y, which is actually what they do here. So they take this guy, negative x plus y equals 3, and they say, I'm going to put it in that y equals mx plus b form by adding x over. So we get y equals, notice again here, we can't put a variable and a number together, so we get x plus 3, okay, a positive x and a positive 3. So that's the very first step that we have here, okay, is to get one of them, just one of them, with a variable by itself, okay? So step number 1. Step number 2, once we have actually gotten one of the equations solved for one variable, then we substitute the expression that we have now, the expression, this portion right here, okay, into the other equation and solve for one of the variables, okay? So what we're going to do is we're going to take this portion, the expression that we found, and we're going to substitute this expression into the second equation, okay? So notice, this is y and this is y. Both of these are y. So if those are both y, then I can replace y with the equation that we found, okay? Just like earlier, we said if this is x and this is 2, I can take x out and replace it with 2. That's the idea behind this, is that I can take, maybe I'll erase this real quick. If these are both y, I can take this y out and put this expression in, okay? So that's what's going to be happening here. So they take the y out and they replace it with the expression that we have found. And then with that, now we're going to be able to solve for x. Notice, there's only one variable now. We only have one variable. So now I only need to combine like terms and solve for x. So I can combine 3x and x. Remember, if we don't see anything in front, there's a 1. So 3x plus 1x makes 4x. And then we have 4x plus 3 equals a negative 1. Well, now we have a 2-step equation. I can subtract 3x from both sides. Or excuse me, not 3x. I can subtract 3 from both sides. There we go. And that would give me a negative 1 minus 3. Same sign, adding, keep the sign. And we get negative 4. Now I have 4x times a negative 4. Divide by 4 from both sides. A negative 4 divided by 4. Negative and positive make a negative. So we get x equals 1. Okay, but that gives us one answer, okay? That only gives us one variable. Then we have to take that and use that to help us find y, okay? So we have x, we need y, so that we have our x and y solution, okay? So that's step number 2. Then step number 3, once we know what the value is from what we found in the second step, we're going to take that value and plug it back into either one of the original equations, okay? So what we found was that x is equal to a negative 1. Whoops. Okay, and this was one of the original equations we started out with. Notice, one of the original equations was this guy. Now, it doesn't matter which one you pick. You just got to pick one of the original equations, and you have to plug the value into the proper variable, okay? So we solve this for x. That means x equals 1. So if that's the case, if x equals 1, then I can take this x out, or excuse me, a negative 1, pardon me, a negative 1, I can take this x out and replace it with a negative 1, okay? I can substitute a negative 1 in for x, okay? Now it just becomes solving for y. Notice, we no longer have x, we only have the y variable. So solving for this, a negative times a negative would make a positive, so I'd have a positive 1. They actually look like they kind of skipped a step, but this would be a positive 1 plus y equals 3. Well, now it's just a one-step equation. I can subtract 1 from both sides, and we would get y equals 3 minus 1 is 2. So I've solved x and y through substitution, okay? So the solution here, remember x and y form a point, the solution here would be the x value was a negative 1, the y value was 2, so my solution is negative 1, 2. Okay, now that's the overview of what we're going to be doing. What I would like to do is maybe work through one or two of these other examples so you can see how it's worked out, and then we'll do the rest of these together in class. Let's do possibly number 1 here, and then maybe we can try one of the harder ones like number 5. Okay, so again, step number 1, you have to get one of the equations so that, or solve one of the original equations so that we have one variable by itself. Well, notice both of these have y by itself. Both of these are in the y equals mx plus b form. So since they're already both solved for y, step number 1 is done, okay? We don't have to go any further. Both of these have y by itself, okay? So step number 1, we're already done there. Step number 2, we have to take one of our equations that has the expression that is solved for and plug that into the proper variable in the second equation, okay? So notice, what this says is y equals x plus 9 and y equals a negative 3x minus 15. Well, both of those are y. So if this is equal to y, I can take this and substitute it in for this y, okay? Because x plus 9 equals y, so I can substitute that value in for this y here, okay? Essentially getting rid of it and replacing it, okay? So that's what we're going to do here is we're going to plug this in for y. So we'd have x plus 9, this is now our new y, that's what we're plugging in for y, equals a negative 3x minus 15. Okay, so all we did was substitute x plus 9 in for y here since we knew that it was equal to y. Now it just becomes solving for x. Notice we have one variable now, okay? So to get x by itself, let's add 3x since we have a minus 3x and get our x's together. Well, we have a x plus a 3x. Remember, that really just means 1x plus 3x. So 1x plus 3x gives me 4x plus 9 equals a negative 15. Two-step equation. I need to get x by itself, but first we need to subtract the 9 over, do the opposite. And we get 4x equals, I have a negative 15 and a negative 9. So remember, we have same sign. We're going to add and keep the sign. So we get 24, and they're both negative, so it'd be negative. We have 4 times x, so the opposite would be divide by 4. So we get x equals a negative 6. Now that's part of my answer. That's just x. We also have to find y. So this is what we were saying earlier on that last step. Once we know what x is, we can plug that value back into either one of these for x, okay? Into either one. Doesn't matter. You'll get the same answer either way. Personally, I want to go the easier route. Since this one looks a little bit more simple, I'm going to plug it into here, okay? So we'd have y equals a negative 6 plus 9, okay? Different sign, what do? Subtract, so we have y equals 3, and since 9 is bigger, it remains positive, okay? So our solution here would be the point -6, the x value, and 3, the y value. So notice our solution is still a point, because that's the whole idea behind this, is we want to know the point that both of these lines, if we were to graph them, that they share, okay? So our solution is -6, 3. Now, of course, you could always go back, plug it back in, and check to make sure that that is correct, but that is the solution that we have here, okay? Now, last one I want to look at here is 5, and then maybe we can do the rest of these together. Okay, so again, first step that we have to apply here, the very first step, is we have to solve one of these given equations for one of the variables. Okay, we have to get one of the variables by itself. Now, if you feel comfortable getting into y equals mx plus b and you want to solve for y every single time, that is completely fine. You do not have to, though. Notice I could get x by itself. This doesn't even have a variable in front of x. We could add the 4y over to this side, and that would get x by itself, okay? So if you want to do that too, that's one way we can approach this, okay? That's the route I'm going to take because we only have to add the y over to get x by itself. So that would get rid of this here, and we'd have x equals a positive 4y plus 9. Okay, so in this example, I'm actually solving for y, okay? I'm actually solving for x, and we're moving y to the other side, but it's still going to give us the same result, okay? Now that we have x by itself, we're going to take our expression here that we found in this guy, and we're going to replace it in this x, or substitute it into the x of the second equation. So notice, we solve for x, so we're going to plug this into x of the second equation, okay? So plugging that in, we'd have a -2 times our new x, which we found to be 4y plus 9, minus 5y equals 8, okay? So that's the idea with substitution. Now, I have a parentheses and a constant, a number in front, and what we need to do is apply the distributive property and multiply it to each term inside, okay? So we'd have a -2 times 4, which would give me a -8y. Then we have a -2 times 9. -2 times a positive 9 is a -18. Minus 5y equals 8. And notice we're only solving for y now. We only have one variable, and that's the point of the substitution, is to go from two variables to one variable. Now, combining like terms, I can put my variables together. A -8 and a -5. We have same sign, add and keep the sign. -13y minus 18 equals 8. Two-step equation, add the 18 over, and we'd have 18 plus 8, 18 plus 8, and we have our -13y is equal to 26. Last step here, we have multiplication, divide by -13 from both sides, and we get y equals a -2. Okay, so we found what y is. We have one of the variables. Now what we have to do is kind of go back to the original equations, see if I can kind of clear things up a little bit. We have to go back to one of these original equations and plug this in for their y, okay? Now again, you can do either one. Me personally, I prefer to go to the one that looks a little easier. So I'm going to use the second one, and I'm going to plug -2 in for this y here, okay? Now plugging that in, we just need to solve for x. Notice I have 4 times the -2, or we could think of it as a -4 times the -2. Well, two negatives would make it positive, so I have x plus 8 equals 9. Subtracting 8 from both sides, we get x equals 1. So now I have x, now I have y, so the solution would be 1, -2, okay? So my solution, the point where both of these equations, if we were to graph their lines on the coordinate plane, where they intersect at, is 1, -2.